This episode is sponsored by Brilliant.org.
Welcome to Quantum Kinetics. I am your host, the CEO, and today we're going to be talking about the one big electron and how the one big electron relates to cold nuclear fusion using the ARC reactor, fusion on demand. So if you're interested, go ahead and stay tuned to the end of the video. So what is the one big electron theory? Well, it came from this guy named John Wheeler when he called up Richard Feynman and said, "Hey, Richard, I think I know why every single electron is 1.6 times 10 to the negative 19th, and you can't change the Coulomb charge because they're all the same electron. There is only one gigantic electron." And the reason he thought that was because the electron is potentially going forward in time in a world line, and then there's a positive electron that goes backwards in time on a world line. And here at Quantum Kinetics, we actually believe that's very true because when we do cold nuclear fusion, we get a lot of antimatter stimulation in the form of X-ray 3.55 keV, which induces a beta decay event in our reactors, also known as transmutation. And so then this theory about the one big electron, we're going to dive way deep into why that actually makes a lot of sense. So go ahead and stay tuned. So before we really dive deep into it, we need to know what situations or environments induce antimatter reactions. Well, first, there's beta decay, which basically is a nuclear reaction. Two, there's cosmic radiation that can induce antimatter particles, and that's when high energy particles collide with each other, basically the same thing that happens in a particle accelerator. And there's also, in the vacuum of space, you can have positron-electron pairs popping into existence. This is also called the quantum vacuum flux, or as some people like to call it, the ether. But in any situation where you have a world line changing from forward in time to backwards in time, and then the positron shows up, you have to meet a certain criteria. And here at Quantum Kinetics, we have figured out how to induce that at a low temperature induced nuclear fusion event. And we'll talk more about that as we go forward. So in the idea of electrons going forward in time in a world path, there's actually no such thing as a straight line path. It's actually curved. Everything in the universe is curved. And it's actually theorized that if we reached our hands together and extended out to infinity, that we would actually go in time all the way here and back to where we began. And actually, Carl Sagan kind of mentioned this. And if you look at this diagram, you can see that the electron has a direction vector going forward in time and will go back into an infinity loop, essentially. But at the same moment, you can see that the positron is also going backwards in time in the opposite vector. And what's between these two particles is actually just a photon of energy that is holding the universe together. And one of the big ideas about why the big electron theory doesn't work in physics is because we can't see the antimatter. There's not enough of it to measure. But you know what's interesting about that? It doesn't mean that it's not there. Can you see the wind blow? No. You can see the effects of the wind blow on a tree. Can you see love? No. You can't see love directly, but you can see the influence of love when people hug or kiss or do nice things for each other, right? So the same phenomenon in physics where the electron can be seen and felt, and then the positrons cannot be seen or felt. But if you agitate them in a very specific way, using particle oscillations as an energy generator, you can get these positrons to pop up into our third dimensional reality from a fourth dimension that you can't see. So using pulsing circuits to agitate the antimatter into existence so we can actually see it from a fourth dimensional down into a third dimensional reality, we can do that using the ARC reactor technology. And in order to do that, you have to use basically integrated circuits. And how I figured out is with Brilliant.org. Brilliant helped me excel in computer science, physics, and most importantly, computer integrated circuits. Brilliant's visual interactive practice sets allow me to refine my ability to design and control resonant logic gate circuits for the ARC reactor. Brilliant's diverse learning exercises range from basic skills all the way up to the advanced levels. Naturally, my favorite learning topics are physics and logic gates. I love it because it feels like a digital interactive video game, and I get to compete with other learners from all around the world at my own pace. In addition, Brilliant.org offers a 30-day free trial period, and best of all, there's a special offer which allows our viewers 20% off annual premium subscriptions. Just scan the QR code or visit Brilliant.org/QKC. which gives you unlimited daily access to everything on Brilliant. So join me as we learn to save the world together. One of the primary places we see time-varying changes in physics is through this thing called beta decay, also known as transmutation or quantum thermodynamics. What does that even mean? It just means that the electron shoots out of a particle, or a positron shoots out of a particle. So if you look over at this diagram here, you can see beta decay positive, which is a nuclear reaction, aka transmutation. The proton can turn into a neutron. And when it does this effect, it actually spits out a neutrino and also a positron. And if you look at beta decay going the other way, which is, by the way, this is going back in time because we see a positron. And also in beta minus, you can see that a neutron can also turn into a proton, thus emitting an antineutrino and also emitting an electron, which means going forward in time. So these two time-varying changes reactions let us know that there is a time flux occurring in that space. And we also should note that when you see an antimatter particle, it's about 3.55 keV X-rays. That's its characteristic. In astronomy, there's a theory going around that there's a characteristic peak near these supermassive black holes or galaxy centers where they have a 3.55 keV emission. And nobody knows on the periodic table what that characteristic peak is associated with. It's not associated with potassium, it's not associated with calcium, but there's one peak at 3.55 keV, and they say that that has a lot to do with time-varying antimatter reactions. If this concept seems difficult to understand, that's okay, because you have to understand in the three-dimensional world where we reside, we're actually technically in flatlander mode. Carl Sagan has a great video about it, you can check it out right here, where he talks about how basically there's only two dimensions of reality that we can really see, but there really are multiple dimensions. There's a third dimension, there's a fourth dimension, there's even a fifth dimension to the universe. And so when you see antimatter, you're actually seeing some shadow of a higher dimension weep down into our third dimensional reality, which you can technically say that it's basically flatlander here. And that's why we can't see positrons all the time. So naturally you're asking, how the heck, how does the universe even stay together, right? So if electrons are going forward in time and positrons are going backwards in time, like two different rivers passing over each other, what stabilizes them so that the universe appears to be stabilized as one giant infinitesimal electron? Well, the answer is the photon. And as we discussed in other lectures, the electron interaction to photonic energy is infinite. It can have infinite degrees of freedom. You can wobble the electron, you can rotate the electron, you can jitter the electron, you can ionize the electron, you can do quantum jumps in the electron shell. I mean, and you can even ionize going electrons with X-rays, and you can even do the gamma rays where it basically does a total annihilation event, which would be when the antimatter and the matter actually touch each other. There is an atomic explosion of pure gamma radiation, which, by the way, is the highest energy frequency in the entire universe. It's like the biggest punch in the face. Gamma ray bursts, we actually talked about that too. You can check out that video, and how the angles of incidence depends on how much interaction the antimatter is stimulating and via particle oscillation as an energy generator. So the answer to stabilizing the universe in this one donut electron shell is essentially photons. The photons are just stored energy in a higher dimension beyond the fourth dimension. So you can think of the fourth dimension as antimatter and the third dimension as electrons. And then there's a fifth dimension, which is a potential infinitesimal light pressure, which is in the middle of the torus that wants to get out all the time. And because the quantum vacuum flux out in space is always emitting a 1.42 gigahertz photon, that's the point of when time varying situations occur where matter and antimatter spawn into existence, making the momentary clock in the universe to spawn one electron, but it's really just the entire universe spawns. And that's what this principle is all about, is about electron-positrons pairs basically creates one single universe, which is our universe, which is one single electron. And so our reactors here at Quantum Kinetics via the ARC reactor can do particle oscillation as an energy generator to stimulate antimatter agitations between the electron-positron pair to emit from this fifth dimensional energy, which is pure light potential, into the universe. And that can go from radio waves, if you do oscillations that are large, to microwave, which are a little bit smaller. And remember, each one of these has a degree of freedom, kind of like a clock, letting the electron know what it needs to do when that specific photon is released out of this universe into another universe. This is also called quantum bounce phenomenon, and you can also check out our awesome YouTube video, music video about the quantum kinetic bounce phenomenon. It's freaking awesome, you should check it out. But essentially this energy of pure love always wants to weep out into our universe from the one big electron. So the one big electron makes total sense because the electron is the entity that can emit every single type of photon via the Bezel function. And you can check out that video in another video that we have about the Bezel function. But you can see that the electron is one universe. It can emit every type of photon. It can actually be influenced by every single type of photon that could touch it or interact with it. It can also emit every single photon that can touch it or interact with it. So if you have specialty circuit designs that can agitate the electron in a very specific way, you can induce radio waves, microwaves, infrared, visible light, X-ray, and gamma. You can also introduce time-varying components to the electron in a localized space or universe, which basically the one big electron is a microscopic universe, and there are multiple bubbles that are nearby that we might be able to jump to if we use this ARC reactor technology. Hope you like this content, and if you haven't already, go ahead and make sure you like, share, and subscribe. It really helps the channel. Go ahead and ring that bell, get this technology to you as fast as possible, and always remember, fusion is love, and love is fusion. You don't have to force it. It just happens. We'll see you on the next one.